Introducing aPriori.
Hello everyone, my name is Allison Leadham. Today we'll be going over design engineering tips for reducing manufacturing costs on new product designs. We will be taking a look at how you can utilize aPriori as a tool throughout the design process to make sure that you are designing your products at the lowest cost that you can. A little about me, I'm a senior expert services consultant here at aPriori. I've been with the company just over 2 years now. I received my degree in mechanical engineering, and prior to joining the aPriori team, I worked as a product design engineer designing headphones at Bose Corporation. You're working on a design for a new product. Of course, you want to design the best product possible that's going to meet all the design constraints, as well as keep the cost of the product as low as you can. As you're designing your product, you might be asking yourself a few questions. What DFM issues might there be with this design? How are my design decisions impacting cost? Am I selecting the best material? Are my tolerances driving any expensive secondary processing? How is product performance impacting cost? Are extra features that I'm adding to improve the product performance worth the added cost that they might be incurring? As a previous design engineer myself, I know these questions, among others, would cross my mind as I worked through different design iterations. I didn't have a tool like aPriori back then to help me answer some of these questions. Especially as a novice engineer in the beginning, I often found myself relying on expertise and guidance of colleagues, or going back and forth with suppliers across the globe, both of which took time and resources. Two things we don't necessarily have a lot of. In today's session, we are going to take a look at how we can use aPriori to help reduce manufacturing costs on new product designs throughout the design phase. We're going to touch on traditional design engineering methods, talk about how we can use aPriori to reduce costs, and then we'll actually walk through 2 design cost reduction examples together. As I go through this presentation, I want you to think about some of the products you've designed in the past. Was there a particular product that ended up being much more expensive than you expected? Was there information you wished you had that would have helped you make a more informed decision throughout the process? Have you ever lost a lot of time going back and forth with a supplier discussing design for manufacturability feedback? My hope for today is that you'll walk away from this presentation with an idea of how you will be able to apply aPriori as a tool for the next product you design. It is thought that 80% of manufacturing costs of a product derive from design decisions that are made in the early design stages. This goes to show just how critical those early design phase decisions can be to the overall cost of the product in the end. Knowing this, it would make sense that you would want to be thinking about the cost and the ease of manufacturability from the get-go. Having this kind of information as a design engineer will help enable you to make informed decisions throughout the entire process. As I'm sure you're all very familiar, as you progress from the design to manufacturing timeline, your design freedom starts to decrease. You're narrowing in on your final design concept. You're designing parts that need to fit together. You're making decisions that impact decisions that are being made by other functions. All those crazy concepts you had in the beginning are starting to transform into an actual product that you're going to start to manufacture. Of course, no design is perfect from the get-go. As you go through the design process, you will likely find there are things that might need to change. But these decisions only get more costly the further along you are. Ideally, we want to minimize the amount of design changes as early as possible to avoid the increasingly expensive costs through the product design cycle. To first reduce our costs, we need to understand what is actually driving the cost of our design. Traditionally, the methods design engineers have to understand cost drivers are going by rules of thumb. This isn't always applicable, so you can't always rely on this. Getting guidance from manufacturing engineers or suppliers, both of which carry a long lead time and are often solicited later on in the design process. In my previous experience, this was by far the most common way for myself to get any insight into cost or manufacturing. I would reach out to our manufacturing expert to get a gut check on ease of manufacturability. This could take a couple of days depending on how busy our internal expert was. I would send the CAD over to our suppliers in China and wait to receive a PowerPoint full of DFM feedback. This was often a feedback loop that went on for a few weeks, reviewing all the DFM feedback, seeing what was feasible to change and what wasn't, going back to the supplier on items they suggested that could not be changed due to product requirements or impacts to the full assembly. Weighing in on the manufacturing risks and deciding what I was comfortable with and what I wasn't. Tweaking the CAD with all the changes and sending it back for another round of feedback. Of course, the time change made for slower correspondence as well. The process, more often than not, was just not very efficient. And it was often the very last thing I would do, gearing up to release the CAD for manufacturing. We know that suppliers and manufacturing engineers are both very busy, so while it would be great to pull them in earlier, you also don't necessarily want to be sending a supplier constant requests for quotes and feedback on designs that might never materialize into business for them. And then lastly, previous experience, which is limited for new engineers and could be out of date as manufacturing technology and capabilities change. I remember the very first part I tried to design right out of college with little to no manufacturing experience. Let's just say my original concept could not possibly be manufactured, but I had no idea about this until I met with some of the more experienced engineers on my team. So, how can we use aPriori to help us reduce manufacturing costs and help us throughout the design process? aPriori is going to provide a lot of useful information that you otherwise might not have. Using the outputs from aPriori, you can quickly identify cost drivers to understand where you should focus your efforts to reduce cost. Whether this be redesigning to optimize expensive features, relaxing expensive tolerances, or changing materials. aPriori also provides DFM feedback to help you understand what manufacturing thresholds are being crossed and which features are difficult and expensive to make, or where you might run into quality issues. You can get this feedback instantly and get ahead of resolving issues you might have otherwise not realized existed until you heard back from your supplier. This gives you the ability to be proactive in your design and streamline the process. Lastly, aPriori provides you with directional feedback. Did that change you just made make your design less expensive or more expensive to manufacture? Is that added feature worth the increase in cost you might incur? Are you in between two design concepts and want to understand which design is more cost effective and easier to manufacture? As a designer, most of what you can affect in cost is going to be your direct or variable costs. And what is that direct cost made up of? It's going to be your material and make costs. Understanding what you can actually impact is key to reducing the cost in your design. For material costs, as the designer, we can take a look at a couple different things. Our material type. Is there a less expensive material that can be used? Or is there a different material I can use that can be manufactured more quickly, such as a faster cooling plastic? Material stock size, taking a look at, am I using a standard stock size or a non-stock size, standard stock size? Am I using a standard or a non-standard stock size? Material utilization, how much material are we actually using and how much of that is going to waste? And then for the make cost, it consists of the labor and overhead. We can influence the cycle time that's required to actually manufacture the part, the number of times the part has to be set up, the type and size of machines that are going to be used, and then any secondary processing or tooling costs. All this information is ready available for you in aPriori once you run your part. Let's take a look at an example using Cost Insight Design. Okay, so I have designed a sheet metal part that is pictured here on the screen. This is the first design iteration. It's a 6mm thick sheet metal part with tolerances on all the holes. It's a pretty thick bracket because the weight of the part needs to hold in the overall assembly. We want to make sure the part is able to hold the weight that's required of it. The issue with this design is that the part became quite expensive. So as a designer, I want to reduce the cost. I want you all to take a moment here and think about how you might go about reducing the cost of this part. First step, of course, is to run it through aPriori. Now, what's the second step once I cost the part in aPriori? As we've talked about, I want to understand what the cost drivers are so that I know exactly what to attack. Where will I get the most bang for my buck? Is it going to be in the material cost or the make cost? I can click into the cost results to get more detailed information about my cost breakdown. We can see here that the majority of the cost is actually in the material. This is where I will want to focus my efforts because this will have the biggest impact on my cost. Now, what can we impact that contributes to the material cost? I can click into the material and process window to learn more about the material I selected. The material utilization tab will show the cost per kg of the material selected and then also the utilization for the part. I can click to the next tab to see the details about the stock size that aPriori selected. And for sheet metal specifically, I can take a look at how a part is being nested on the selected sheet. In aPriori, you do have the ability to set your utilization to true part nesting, which will orient the part in whatever way to allow for the greatest utilization to be used. Rectangular shape nesting is going to orient the part all in the same direction, or you can override the percentage to a user default if needed. Next, let's take a look at the design guidance that aPriori provides. You can see we have a DFM risk rating of high with 47 design warnings for this part. There are various DFM issues that are being flagged here. As you click on each issue, the associated features will be highlighted on the CAD model. You can see we have a few different proximity warning issues: hold to bend, hold to hole, and hold to edge. I've clicked into the hold to bend proximity issues, and you can see all the GCDs that have a hold to bend proximity issue are actually highlighted on my model. aPriori will also let you know the current distance between the hole and the bend and a design suggested distance to resolve potential manufacturing issues that might arise with the current design. If you are unsure exactly what the issue is, you can click on the blue light bulb for more information. The information box will illustrate the issue as well as explain potential problems and provide guidance for how to take action to resolve the issue. Let's continue to take a look at the other issues aPriori has flagged. On the left, we have aPriori flagging tolerances on these holes. The holes have a diametrical tolerance that is too tight for the turret press, driving an additional operation to meet the tolerances. If we could relax the tolerances to the suggested 0.06 millimeters, the holes would be able to be made on the turret press. On the right, aPriori is flagging a minimum diameter issue with the other holes. The turret press can also not make these holes, or it might break the tool. This is also driving an additional operation. So let's take a quick look at the process routing to understand how aPriori is actually manufacturing these holes. We can navigate to the process window to take a graphical look at the cycle time breakdown by each process. As you can see here, 43% of the cycle time to make this part is actually going into machining these holes. We now have learned that we are adding additional machining operations to our sheet metal part that are almost double the cycle time. I want to note that this process graph can be sorted both by cycle time and fully burdened cost. We're looking at the cycle time view right now. Let's go back to our design guidance. We can navigate to the process window to take a graphical look at the cycle time breakdown by process. As you can see here, 43% of the cycle time to make this part is going into machining these holes. We have now learned that we are adding additional machining operations for the sheet metal part that are almost doubling our sheet metal cycle time. I want to note also that this is a process graph that can be sorted both by cycle time and by fully burdened cost, and we're taking a look at the cycle time view right now. Let's go back to our design guidance to get a little more information. If I click into the investigation tab, I can review a number of different items: the number of non-standard tools and number of unique tools. Using non-standard tools and too many unique tools can actually increase your manufacturing complexity and cost. aPriori will point this out so you can try and minimize the number of unique and non-standard hole diameters and fillet radii that are on a part. In a similar vein, the investigation tab will also let you know the number of distinct feature sizes that there are on a part. You can also view the number of machining setups and the number of machined features, both of which can incur additional costs. And lastly, any specialized finishing required for any features that will also drive up the cost. You can click into any of these categories to understand what GCDs are being affected. If I click into the machining setups topic, I can see this part requires 2 different setups to machine the holes. You can click on each setup to see which features are being manufactured under them. The yellow arrow illustrates the setup direction. Not only do we have additional machining steps in our design, they also require 2 different setups. So, using all of this information we just reviewed in aPriori, let's brainstorm the different ways we might reduce the cost of this design. So the majority of our cost is in material cost. What can we think about to change here? Can we change to a different, less expensive material without compromising the function of this part? You can actually review the material database in aPriori to see how different materials compare in properties and in unit price. Can we select a stock form that would be less expensive? Can we change the design to improve our utilization % to reduce waste? How about those additional machining steps? Do we need the tolerances on those holes, or do we have room to relax them? Can we change the diameter of the 2 smaller holes so that they can be made on the turret instead of being machined? I went back to the drawing board and redesigned the part with this in mind. I decided to try and make the part out of a thinner stock size and choose a harder material to make sure that the part was still strong enough. I also went back and realized I could relax the tolerances on the holes a little bit. Let's now run our new part in aPriori to see how it compares. So here's our first design iteration, option 1. We've reduced the thickness to 4 millimeters. We've changed the material from steel 1020 to steel 4140. Using the material database in aPriori, you can easily compare the material properties. The stronger material is a little more expensive, so we're going to have to see how that impacts our cost too. First, let's take a look at the process tab. So here's the first design iteration, option 1. We've reduced the thickness from 6 millimeters to 4 millimeters and changed the material from 120 to 4140. Using the material database in aPriori, you can easily compare material properties. The stronger material we can see is a little more expensive, so we're going to have to see how that impacts our cost as well. Running design option 1 in aPriori, we've actually reduced the cost by $12. However, taking a look at our process window, we still have additional machining operations that are happening on our part. Let's go back to our brainstorm. What if we stay with the 4 millimeter stock size, but change back to the original material, since that material is less expensive? We will have to tweak the design a little bit to ensure that the part is still strong enough. Let's run our new part in aPriori to see how it compares. So for design option 2, we've reduced the thickness to 4 millimeters again, but instead of changing the material, we added gussets for strength to keep the original material. Looking at our process tab, we can see that we actually no longer have any machining operations. Changing to the thinner stock in the 1020 steel allowed for the turret press to actually be able to make the diameter hole necessary for the design. I can then use the cost comparison function in aPriori to really understand how the 3 designs compare in cost. Let's take a look at the results. In aPriori, you can run these design comparisons against each other to see how they compare in material, guidance, processing, and costs. We can see how design option 1 and 2 both compare to the original design. You can do a cost comparison of up to 10 parts in aPriori. One thing to note here is that for the comparisons, the parts are always being compared to the very first part. So we can see our middle part is being compared to the first part, and our third part is also being compared to the first part. We can see based on this comparison that our final design, option 2, is lighter, the utilization has improved, the overall cycle time has decreased, and every aspect of our cost was decreased, saving us a total of $17 per part. And all we had to do to figure this out was click a few buttons to get this instant feedback. All right, let's take a look at another example. Using everything you've learned so far in this presentation, we want to try and reduce the cost of this machine part. Think about what we should do first. Well, we want to take a look at the cost breakdown to understand what's driving the cost. We can see here that most of the cost is in labor, overhead, and other. All of these are attributed to the make cost of your part. From here, we need to understand what is actually driving that make cost. Let's take a look at the process breakdown. In the previous example, we were looking at this graph sorted by cycle time. Here we're going to look at it sorted by cost. You can see the majority of the cost is actually coming from the 4-axis mill. We have drill press and reciprocating grinding operations, but they are really very minimally impacting our cost. Take a second to think about what we should do next to understand what's actually driving the cost of our 4-axis mill process. Did you think that we should check out the design guidance information to see what we can find? If so, you're absolutely correct. Clicking into the design guidance tab, we see that we have a number of machining issues for this part, most of them being the side milling length diameter ratio issue. What this means is that the tool required has too high of a ratio between the length and diameter, which may cause the tool to deflect. Tool deflection can lead to chatter, reduced tool life, inconsistent final dimensions on your part, and poor service finish. This ends up driving higher cycle times because in order to decrease the force that is pushing on the tool, you need to slow it down. Next, we can click into the investigation tab to take a look at the machining setups, any slow machining operations, and features that require specialized finishing. If we take a look at the slow machining operations, we can see which features are slow operations. Right below that, we have our features that require specialized finishing operations. You can click into each operation to see what features need the different specialized finishing operations. You can view the current tolerance as well as the basic machining threshold tolerance for the process. So, question for you all. Looking at this information, which should we focus our efforts on for cost reduction and why? Should it be the slow machining operations, the specialized finish GCs, or neither? The answer is neither. If we take a look at the cycle time percentages here, we can see that with the slow machining operations, they amount to less than 3% of the total cycle time. And the specialized finishing operations amount to less than 1% of the total cycle time. If we focus on either of these areas, it's not going to make much of an impact to our overall cost. So I take what I learned from aPriori, went back to my design, and I made a couple changes to the fillets to improve the length to diameter ratio issue that I was seeing before. We can see that our side milling machining issues actually went down from 22 to 2. We can go back to the process window to compare. What did that do to our cost? We can see that the cycle time actually decreased from 1,500 seconds to 1,100 seconds. This ended up saving us $68. Using aPriori, we were able to use the design guidance feedback to hone in on what was driving a lot of the cost, make an informed design change, and then quickly rerun the part in aPriori to understand the actual cost impact of that decision. There was no guessing involved and no wasting any time trying to make changes that wouldn't end up moving the needle much. One last thing I wanted to touch on, and we're not going to walk through an entire cost reduction example here. Can I use aPriori to understand the tooling costs for my design? The answer is yes. When I was a design engineer, I designed primarily plastic parts that could get quite complex. I had little to no insight at all into how expensive the tooling for my parts were going to be until I was receiving parts from the supplier. Let's take a look at a plastic part in aPriori. If you find that the tooling is a significant cost driver for your part, you can take a look at the design guidance in aPriori to learn more. Under the Investigation tab for plastic molding, you will see the topics of sliders and lifters and specialized mold tooling. You can click into the individual topics to understand what is driving any specialized tooling. You can see for this part, we have 2 lifters that are making the 2 highlighted holes on the side. We have 2 slide bundles as well, and you can click on the slide bundles to highlight the features that are being manufactured by those particular slides. On our right, we can take a look at our special molding tooling. This is going to include things like threading mechanism, ribs, and grills that all incur additional hard tooling costs. If tooling cost is a large cost driver for your design, it is definitely worthwhile to check out the design guidance to understand what features might be incurring additional tooling costs. Is there any way you can redesign the part to reduce the number of sliders or lifters? I hope these examples were helpful in showing you how you can use aPriori to reduce costs in your design. In review, the steps for cost-reducing designs are first, identifying your cost drivers. Is it the material or the make cost that is making up the majority of the cost? This will allow you to focus your efforts where it will make the most impact. Second, review the DFM feedback provided by aPriori. You might find that there are certain features that are very expensive or even impossible to manufacture. You might find out that there's the potential for you to run into quality issues, and you can then take steps to mitigate any quality risks if the design constraints allow. Third, check out the Investigation tab. Depending on the process, there will be different things that you can learn about the manufacturing cost of your design. And lastly, implement your design changes. Using all this information you can gather from aPriori, make informed decisions on your design. Recost the new design to understand the cost impact of your decisions. In conclusion, aPriori is a powerful tool that can be leveraged as soon as design concepts have CAD data. aPriori will arm you with the information needed to aid you, the designer, in making the best decisions for your product. Whether that's understanding how to balance performance versus cost, reducing the risk of manufacturing quality issues, or understanding the cost drivers and how to reduce them. The best part is you can do it all yourself in minutes with aPriori. I just wanted to take a second to thank you all for listening to this presentation. I hope you enjoyed it and were able to learn something today. Thanks.
aPriori, making profitability and sustainability a reality for a better world.